There are 6 trig functions. At this point, we know the derivatives of 2 of them. We have shown that the derivative of sine x is cosine x, and we've shown that the derivative of cosine x is negative sine x. Now for these two, we pretty much had to use the limit definition of the derivative because we didn't have any other knowledge about derivatives of trig functions. But the other 4 trig functions can be written in terms of sine and cosine. So we don't need to use the limit definition of the derivative. Let's just take a look at tangent. If I wanted to take a look at the derivative of tangent, I can use the quotient identity that tells me that this is the derivative of sine x over cosine x. That's a quotient. We know the quotient rule. So I can just apply the quotient rule and my knowledge of the derivatives of these 2 trig functions. And something similar is going to work for tangent, cotangent, secant, and cosecant. So once we've got the first 2 done, the remaining ones are going to go a lot faster. All right, using quotient rule, I know that I'm going to get low, that's cosine of x, d high, that's the derivative of sine x, minus high, that's sine x, d low is the derivative of cosine of x, all over, square the bottom, and away we go. Okay, let's go back and evaluate those d by dx's. The derivative of sine is cosine. So we've got cosine of x times another cosine of x minus sine x times the derivative of cosine is negative sine. Now if I bump that negative sign to the front, that's just going to become a plus. So we get sine x times sine x over cosine squared x. Now notice on top, that's cosine squared x, because cosine times cosine is cosine squared, plus sine squared x over cosine squared x. Cosine squared plus sine squared, that's 1. So we get 1 over cosine squared x. Now, that's a correct formula. Usually, you'll see this written in a different way. That's equivalent to 1 over cosine of x quantity squared. Because, of course, if I square the top, it just gives me 1. And if I square the bottom, it gives me cosine squared. But 1 over cosine is secant. So usually you'll see that written as secant squared of x. Now, when you're taking the derivative of tangent, if you write 1 over cosine squared or you write secant squared, they're the same thing. You're free to use either version. But we've just shown that the derivative of tangent x is secant squared. What I'm going to have you do before you watch the next video is work out the derivative of cotangent. It's going to be very similar to this because cotangent is just cosine over sine. Work that out, then tune in and we'll go over it together in the next video.